Hello everyone, I hope you're doing great today. My name is Yoann Jestin. I am the CEO and co-founder of Ki3 Photonics, university spin-off from Montreal, Canada, and we are building quantum photonic hardware for the deployment of quantum communication networks. So we'll hear a lot about quantum computing in these days, and one very important thing to consider in this case relates also to the quantum ecosystem that is growing around it. Indeed, in the next years, there will be an increasing number of devices that will make use of quantum technologies, and in order to take the maximum opportunity of their capabilities, such devices will have to communicate with each other in order to exchange information, or, for example, increase our processing capabilities, for example, through distributed quantum computing. Ideally, they will do so through the current optical fiber network we are using every day to communicate in order to form a quantum-enabled internet. Unfortunately, to date, most of the existing quantum links are only restricted to two users, usually called Alice and Bob. So, at Ki3 Photonics, we are building quantum photonic hardware to support the transit of quantum information into a network configuration and enable the distribution of quantum resources for multiple users. And for this to happen, we are focusing on three very essential requirements, which are the universality, the scalability, and the multi-channel information processing, which means that we want to have a quantum channel and a classical channel all wrapped together in the same optical fiber. So in details, we are basically building a multi-channel source of photons. This source of photons can generate entangled photons over an optical frequency cone. By using integrated optic component and off-the-shelf telecommunication components, we can generate quantum signals over 50 ITU communication channels, spanning the S, C, and L bands of telecommunication. So this is really a key element if you want to do frequency multiplexing, and also the pulse nature of the source makes it an ideal candidate for the generation of high-dimensional quantum states for further interaction, for example, with quantum memories. So here it's really thanks to the nature of the source that the notion of quantum networks really makes sense. Imagine just one single device that can generate up to 50 different communication channels and feed those communication channels with quantum signals, while the competition stays limited to one. So, as a key takeaway here, this source is compact, works at room temperature, and telecom wavelengths. We'll take pre-order for Q1 2023 and shipping in Q3 2023. So if you want to build a quantum network, this is really the kind of source that you're going to need. Indeed, there's going to be a huge market opportunity with quantum networking. It's supposed to represent a $5.5 billion market in the next 3 years. And we can see application in quantum networking, like, for example, distributed quantum sensing, but also distributed quantum storage, private auctions through oblivious transfer, things like this. We can also have entanglement distribution and something more classic with multi-user QKD. So how do we want to generate revenues? So a little bit like classical telecommunication provider is selling you bits of information, we want to sell you quantum bits of information. We want to implement our hardware into the existing optical fiber network that we are using every day to communicate. We're going to generate quantum information, manipulate this quantum information, and distribute it to different users. So to date, we are a team of 11 people working on this. Me, PhD in material science, my co-founder, PhD in quantum optics. We have more than 20 years of experience in integrated optics, fiber optics, quantum optics. In our mission, we are helped also with a technician that is a master in packaging our device, making things working with the electronics, and also a business consultant that is working with us in order to try to identify some use cases. We are also working with postdocs, supporting PhDs through collaboration with universities. So to conclude, I would like to mention that we'll soon have access to a commercial quantum testbed in the region of Quebec, Canada. We want to implement our hardware into this testbed to manipulate, generate quantum information. So if you are an early adopter or an investor that wants to support the deployment of our device into this network, please reach out. I would like to thank the different partners here. My name is Yoann Jestin. I'm the CEO and co-founder of Ki3 Photonics, and I thank you for your attention.
Thanks. We have time for some judge questions.
Thank you for the presentation. It was a good one. So currently, it seems like there's a test bed that you'll be utilizing to test this out. Eventually, what will be the go-to-market target, like government contracts or more private industry? Where would you think this seems fit?
It's basically both. Actually, we can see that the government also are very interested in deploying these really commercial test beds rather than being more focused with academia. And there are also some companies, there are some quantum test beds that are implemented in the US that are really based on commercial applications, trying to set the standards also for this. So it's really a mix between both of these. And there's also, of course, the Army, the defense, that is very interested in testing some use cases onto those test beds.
Just a quick follow-up. Any metrics, specific metrics that they'll be comparing you against the incumbents? Is it like more throughput, or what different metrics would you be basically
Can
banking
you repeat
it
the
on?
question? I don't hear it well.
Metrics that they'll be basing, like let's say it's a competition with whatever is the incumbent fiber optic solution, right? Like what will stand out by using your technology as compared to what is already there?
So
advantages or metrics, performance.
Differentiation between... So here the differentiation that we have with our technology is really to be able to distribute for multiple users. So it's really trying to use also the classical techniques that are used in communication with classical frequency comms in order to increase, let's say, the scalability also of the network. So you have one single device rather than that can generate up to 50 different communication channels, rather than one single device that can also just run. So here it's really the compatibility with the existing technology that we have in classical communication and really try to adapt this to quantum.
Thank you.